Let's begin. Okay, so this is exercise 20F. We got into kinematics, and we're just gonna just on this page here, for those who weren't here on the day, and I'm recording this, just to recap a couple of things. There are three terminologies that you learnt. Three things. What was one of the things? First one, starting with D. Ben, give me one. Terminologies. Distance versus? Okay, good. So we've got displacement versus distance. Good. Displacement versus distance. Yep. So this is your first term. What displacement means. Second term. What were we also comparing?
Velocity versus speed.
Good. Velocity versus speed. I want to quickly go through it as well later. And then what was your last term? Acceleration. Okay, now here we go. Acceleration, what we had to understand was the difference between displacement and distance. Now, the example I gave to you yesterday was saying that, let's say if I was standing up on stage right now. This is where I'm standing right now. Yeah?
Where is this displacement?
I'm going to describe distance and displacement and difference between the two. Yeah? If I told you that I'm moving to the right by 3, you would say that, okay, I'm moving to the right by 3, which I land here now. But then let's say I decide to now move to the left by 7. Okay, so if I decide to move to the left by 7, then this would make me now at this point here, which is -4. True? Okay, if where I'm standing is the origin. So if this is the origin, then I move from 3, take away 7. So I moved all the way here, that's a 7. Okay, so 7 units there. Then what's the difference between displacement and distance? Distance is how far I've traveled. It's regardless of where I started. It's just more about how much is the distance I've traveled. It's the overall unit. It has no directions to it. So in our case, I've moved 3 units to the right, which is over here, and then I moved an extra 7 units. It doesn't matter whether it's right or left. I just moved 3 and then I moved 7. So my distance is equal to, I've moved 3 and I added an extra 7. So you'd say I've moved 10 units in total. Fair call? Whereas displacement takes into account where I started. So because I started at the origin, though I moved 10 units in total, I've only landed back -4 units to the left of the origin. Okay, so that has a direction. So displacement, my displacement is relative to the origin. I am now -4 units from the origin. Okay, so that's just recapping what displacement was. Then we went to the difference between velocity and speed. See, that means speed is the total distance you've traveled, which has no direction, over time. Okay? Which also means to find out your distance traveled, you've got your initial distance and your final distance. So another way of thinking about this is you can have d2 minus d1 over t2 minus t1. How long does it take you to move from one point to another? And how far have you traveled from one point to another? Yeah? That conveniently gives you the derivative. That's the change in distance over change in time. Okay, so that's what speed was. Whereas velocity is the change in displacement, which we use the letter x to represent, over the change in time. Conveniently, this just basically means it's the derivative of my displacement equation. Okay? And then lastly, acceleration means how fast you're measuring the speed of your speed. Okay, so the speed of your velocity. Okay, so what you're really doing here is you're saying acceleration is equal to the change in your velocity over change in time. Okay, so from one velocity, what velocity did you start off with, and your final velocity over what duration? Yeah? That's why this is now the derivative of your velocity equation. Okay? So those were the only terminologies I taught. I taught displacement, velocity, acceleration, and the only extra thing you had to understand how the derivatives come into play. Okay?
Mr. Trent, is the derivative the top thing or the whole thing?
The whole thing. So this is the derivative of your displacement, whereas the acceleration is the derivative of your velocity.
But then, so does that mean derivative of displacement? Does that mean
You have to be given a displacement equation to start off with.
you would not be able to take it? You have to put your own t.
So when you write a displacement equation, it'll be in terms of t. So it will be like x will equal to, I don't know, let's say t squared plus t, right? Then if you want to find velocity, velocity is dv dt. It's the derivative of your displacement. So your velocity will equal to 2t plus 1. If you want to find your acceleration, acceleration is the derivative of your velocity. So if you find the derivative of 2t plus 1, acceleration will now equal to 2.
Oh, so does that doesn't have to be a triangle? It can be a dv instead.
Oh, yeah. I'm using triangle. Triangle means delta. Delta means change. I'm just using different symbols to describe the same thing. So you can use D, which means change. Or D actually means delta. That's what the D is for. That's why it's not written like... I know when I write it, I'll write it like a letter D, but technically you should be writing it with a curve. It'll look like that. dy dx. And that means delta. Okay? Alternatively, you can use the triangles that I'm using. Triangles means delta. Okay? All right, now let's go to a question. Let's apply this knowledge. Okay? We have a particle, and it moves along a straight line. So again, it's moving in a straight line. So I know visually, this is my line. I've got a particle, and it's moving. Okay, I just don't know what speed it's moving at. I don't know where it's starting at. I don't know anything about it. I just know it's moving. Okay? Now, I know that it's measured by t seconds, and it's a distance from its origin. Okay, so let's say the origin's here. I don't know if it's starting on the origin. I don't know if it's starting away from the origin. I don't know anything. I just know, let's call that the origin. Okay? All we have now is an equation for my distance. Okay, it says s meters is the distance from the origin. Okay, so this is technically telling me my displacement. That's what it's telling me. Okay? Because it says from the origin. If it's relative to the origin, then it's a displacement. If it didn't talk about that, then it's distance. Okay, so now I know that this is displacement. Let's answer the first question. The first question says, when is the particle at the origin?
Wait, is that O?
Yep, O means origin.
Alright, so does it mean it's O in the question up there? That's the origin of the question, the actual question.
Is in this picture here.
No, up in the question, second in...
From O.
Does that mean origin?
Yep, this O means origin. Okay, so now to find, yep.
Its origin, does that mean like origin only this way or does it go on?
Yep.
So it's always going to be like 0, 0.
Not always 0, 0, depending on the equation.
So
Yeah.
because in this, it doesn't actually like say that it's at origin. Like the origin of the straight line can be some other
Yeah,
point.
yeah, you're right. You're right. And in this case here, it's a bit particle at origin. I guess in this case they're talking about your graph, but you're right. Normally, what they should have said in this question here, it should be written as where is the particle relative to the origin initially? Then that makes more sense. Then you know it's the Cartesian plane. Yeah, but when you write it like that, yeah, we don't know because if we don't know if it's when t equals 0 or we're talking about at the origin because origin would be 0, 0. In this case, obviously it has to be at away from the origin. It's when t equals 0. Okay, so when we're asking for the origin, we're really asking
Where it starts.
where is it starting, and when it first starts, time is 0. Yeah, because when you measure the particle at the very start,
But it can be like 0.
yeah. Yeah, exactly. So at t equals 0, let's work it out. Your displacement, S will equal to 0 cubed minus 3 times 0 squared plus 2 times 0. And interestingly enough, it is at 0, 0. Okay, so that tells me that the particle starts right at the origin. Okay? We good? All All right, cool. So that means we know on your graph, if it was a displacement by time graph, I know at the initial point, I'm starting right at 0, 0. Just because in this particular case, when t equals 0, the distance is 0 from the origin.
You can't assume when it says the origin of the particle, you can't assume that's 0.
Because we don't know where they will start. They shouldn't have, yeah. They should. That's what I'm saying. I'm saying that they should have used the word initially. If they said initially, you just start with t equals 0 and find your position. But it sounds a bit stupid to say the origin, because then it's obvious that it'll be 0, 0, unless the equation models it. Yeah.
When they say origin, it means start. That is, then if they say origin.
If it says origin, what you're meant to take is t equals 0. I know it should be said initially. That's what it should be said. But in this particular case, in what this question's asking, they're asking you to find it when t equals 0. That's what they're asking.
They're just trying to confuse you with the questions. So if they just said,
Yeah?
same letters, X and X and X.
Yes. Now, let's go into B. Let's go into B. Now B, I've got my first picture. I know that I start at the origin, exactly on the origin at t equals 0. It says, what is the velocity and acceleration at these times? Okay, so at these times, so it looks like find my velocity at that point, find my acceleration at that point. Now to find velocity, from what we just knew before, velocity is the change in displacement over the change in time, which really just means the derivative of your displacement equation. Now your displacement equation was given as s is equal to t cubed minus 3t squared plus 2t. So therefore, it should be the derivative of your displacement equation. And we know the derivative of t cubed minus 3t squared plus 2t is 3t squared minus 6t plus 2. Good. So that's my velocity equation. And my acceleration equation, which is the derivative of my velocity. So acceleration is the change in velocity of a change in time. Yep, because we're measuring the change in velocity, and so it's the derivative of this. Okay, so acceleration now, finding the derivative of 3t squared minus 6t plus 2, that gives me 6t minus 6.
When is the particle's origin? Well, why wouldn't it just assume displacement is 0? It may move somewhere back, where it can be at the origin.
Yeah, we can be at the origin.
So there's different answers for t.
Yep. Oh, wait. No. Origin usually means when you start the time. So when you start the time is when you begin. But it doesn't mean that when you start the time, you're actually at where the origin is. Do you know the example yesterday? I said if I'm moving right now, see I started there, but I have a timer now. Now I can start the time now. So if I start the time now, I am currently 3 meters away from the origin. So it doesn't mean when I start the time is always 0 at the origin. Okay? So when I first start, t is always 0. So where my position is relative to where I started, that could be anywhere.
And then if you go back, does that mean your displacement is 0?
Yes, if I go back to the C, now this is depending on when I started the time. If I started the time here, this is when t equals 0, and I'm moving, then my displacement here is 0. My distance is 3 meters. Yeah?
Is it 6 though? Because you went there and back.
No, it depends on when you start the timer.
But does that mean your displacement is 3? Because your origin.
Yes, exactly. So if I started the time here, displacement is 3, distance is 0, time is 0. But when I walk over here, it depends on how long it takes me. If it takes me 2 seconds.
What? Wait, so you go back over to
Okay, I'm going on the
Is
way.
this your origin?
No, that's where I started.
No. Your origin. Like your origin. The one the origin they list in the book.
Then my initial point.
Your initial point there, yes.
Yes. So
But if you go back to your C, which is your origin,
Yep.
is that your displacement 0?
Yep.
But then your distance is 6. Because you went there and back. It's 3 meters.
It's only 6 if I started my time over there.
So it's only 3 to start time.
But yeah.
But if you walk from there to here and back So your displacement is 0, but you have a measure of 60.
Yes.
So displacement is measured from like 0, 0 on the graph, and distance is measured from 0. So
No. Displacement is measured from the origin.
distance is measured from the origin,
Displacement
and displacement is measured from.
No, this is measured from the time scale.
Yes, that's correct.
Yeah.
So distance
The origin.
Yes, but then displacement is measured from the origin, which is like the 0, 0.
Depends on what you mean by origin. If origin means like where
That's
am
why I
I
was making the head. It's like the origin of like
on the
The
graph?
origin.
the origin of the graph
Okay, now what graph is
is
that?
where
Is that a distance by time graph or is that a
Yeah.
displacement by time graph?
But it's going to still be on 0.
Okay, now let's go back to, do you understand when I said that's where I started off my C?
Yeah, but what kind of graph are you on?
So let's call that my origin,
which origin.
which means that that's where
Which
it
is
all
that your
starts.
initial
That's
start?
where my seeding starts.
Wait.
So that's my origin.
So you start your time there.
T is 0.
So that, okay, good. So now, so that's what I mean. It depends on where T is. If you start your timer here, and this is where my origin is as well, okay? Then T equals 0, O equals 0, I mean displacement equals 0, and distance is 0, yeah? But if my origin is always here, let's call this O for origin, and I'm gonna walk over here, which don't count this, because I haven't started the timer. It's when I start the timer.
Yes.
If I start the timer here, okay, this is my initial point. My distance is still 0. My displacement is 3. So I'm 3 meters away,
Displacement is from the origin.
which is there.
the center one. It's always 0, 0.
Depends on what the graph is. So, do you understand? That's O.
Yes, I get that.
Okay,
but then
great.
the question says your row as well. Like it's his
No.
origin.
That's why I said. That's why I said. Ignore what the question's trying to say. I said they used the bad language. That's what I said. I said the question is bad. I said it should have been written as initially.
But
That's
is
what I
that
said.
what all
So
questions
let's
are
get
written
the
on?
questions. Come on.
No,
So I'm going to get
but so if you understand what I'm saying, it sounds like you already do. You're being pedantic on the word origin here, and I'm saying that ignore that. It should be initially. You're absolutely right.
Alright,
It
so
should be
you're
initially.
now initially.
Yes.
If you go back there,
Then that's
displacement 0
Yes.
from the origin. But then your distance is 3 initial.
Yeah.
And your time is whatever.
Yeah.
It's 0.
Yes.
But then he's now there for time.
Yes. This can.
They said that origin doesn't have to be at 0, 0, correct?
It depends on. So if you're drawing a displacement graph, then this point will always be O, which is 0, 0. But you see, when time is 0, because this is time, when time is 0, it doesn't mean your displacement has to be 0. It could be 0, 6. And that's what I was trying to demonstrate. I was trying to say, this is my origin. Okay, so if this is my origin, I'm going to put this here. That's my origin. I don't have to start the timer there. See, that's 0, 0. This is when, if I start the timer here, this is 0, 0. But if I don't start the timer there, and I'm standing over here, and I start the timer here, then my displacement is 3, but my time is 0. My distance is 0, because I'm starting the timer here. Distance is based on when I move. When I start the timer, when I move. Yeah? So if I start the timer here, I'm currently that far away from my origin. That's why the origin I was just trying to say, T is always 0, but your displacement can be anywhere, which we don't know. Yes?
So what's the point of the origin?
What's the point of the origin? You need a point as a reference when we're talking about displacement.
But that could be anywhere.
No. Displacement can be anywhere. I can be anywhere. The origin's always there. I can be anywhere. I can be over here. I can be over
And
there.
what would your displacement
But
be?
it's like, how far am I from the origin?
And you can calculate that.
From what they give you. From the equation they give you. Because when they say a particle's moving, it could have been moving this far, it could be moving this way, and they start the time here. So that's why when you let t equal 0, which is what we did here,
See, when we let t equal to 0, it so happens that you are currently at the origin. But in the example we did yesterday, see in the example yesterday when we did kinematics, if we have a look at this equation here, wait, not this equation, where is it again? This one. See that equation, if I asked you at t equals 0, your displacement, find its initial position. I was at 0, 0, that makes it 0, 6. So that means the particle was measured when it was 6 meters away from the origin. So the origin is always a point, but where you start could be anywhere. And time will be 0 initially. That's why I'm saying the question that you just read just now, they worded it poorly. They shouldn't have said find where the origin is, because the origin is obviously 0, 0, but they should have used the word initially. That's what I'm saying. So I'm saying don't be pedantic, just understand what the question is trying to ask. Just work with it. Because I'm just trying to teach you what displacement means, distance means, how do you find velocity, how do you find acceleration. But if you're going to be pedantic on the word, I'm like, yeah, you're right. It's true. It should have been initially, but it doesn't mean that you can't do the question. So I'm trying to teach you the theory to do the question. That's what I was trying to say to you. But in terms of what you're saying, the origin is always fixed. But where we are relative to it, we don't know. And the only way to know is when t equals 0, that tells me where my initial position is. Does that make more sense? Perfect. All right. Let's roll onto, where are we up to now? Velocity, was it? Question B. Finally. Now B. B was to find its velocity and acceleration at these times. So when you were finding when is the particle at the origin? Yep.
Do you have to change your graph now, but like its velocity and acceleration now?
If you're drawing the graphs, yes. Yes. Now, I just realized I did the question wrong. Makes sense. It says when is the particle at origin? It means when the displacement is 0, not when time equals 0. Is that what you were trying to say? Oh. Okay. Which makes sense why the second question asks is for time. That's why. So, let's take a step back. We're saying when displacement is 0. That's what the origin means, yeah? So that makes sense. So when s equals 0, you now have 0 equals to t cubed minus 3t squared plus 2t. And if we calculate this now, this gives me what? Take t out, that becomes t squared minus 3t plus 2. 0 equals to t bracket 2, 1 minus minus. So therefore you got t equals 0, t equals 1, t equals 2. Have I done this too fast? We got this? Okay. So what this means, they asked you when will the particle be at its origin. It looks like it's going back and forth to me right now. So it's passing the origin a couple of times. It passes the origin when t equals 0, starts at the origin. And then after 1 second, it somehow comes back. So after 1 second, it comes back. After 1 second, it's back at the origin again. Then after another second, it seems to come back at t equals 2. Okay, so now I'm not drawing the graph. I'll draw the graph. Here we go. So ST, if that makes more sense. If we're drawing the graph, we're saying it crosses the origin at 0, 1, 2.
Yeah, that's fine.
Which makes sense. You see, what I'm trying to say is it went to a certain distance. It had to come back to the origin at 1 second. After another second, it went another direction, and it came back and landed. That's why I drew the other diagram. But if you prefer the cubic, I'll draw the cubic.
Oh, you can do both.
Okay? I don't want to confuse you, that's why. Okay, so this is the displacement time graph. The other one was a visual representation of what a particle means when you're moving in a straight line.
You can draw that next time.
Okay, so if I draw it next to it, you're not going to get confused, right? So here we go. We've got,
Just label.
so I'm going to label here. We've got, this is displacement time graph. This is just a diagram. So I'm going to write here diagram. If this was origin, you're starting at t equals 0. You started here. That's where the particle is. It's moving in some direction. I don't know which direction, but I know after 1 second, it comes back. So at t equals 1, it's back at the origin. Then after that, it's going to keep going in that direction, and then it changes direction and comes back at t equals 2. So that's why at the origin, there are 3 times where it crosses that point. Okay, this is just a visual representation of what the particle's doing. It's just moving back and forth. Okay? Whereas the one on the left here is your displacement time graph. Okay, so it talks about your displacement. This is where displacement is 0, displacement is at the origin again, and displacement is at the origin again. Cool? All right. Now, continue on B. So B says find the velocity and acceleration at these times. We have t equals 0, t equals 1, and t equals 2. T equals 0, t equals 1, and t equals 2. So if we're finding the velocity of each one, t equals 0 would mean that I would now have 3, 0 squared, minus 6 times 0 plus 2. That gives me 2. Okay, so that's the velocity at t equals 0. Anyone confused there? Okay, next one. It'll be 3 at 1 second. This will give me 3 minus 6 plus 2, which is negative 3 plus 2, negative 1. Okay, and then finally 2. 3 times 2 squared minus 6 times 2 plus 2. What's that? 12 minus 12, 2. Okay. If we work out for our acceleration would now be 6 times 0 minus 6, which is negative 6. 1 would then be 6 minus 6, 0. And then 2 would be 6 times 2 minus 6, which is 6. Okay? That's answering B. So you can see that all I'm doing right now is I'm just looking at displacement, velocity, acceleration. I'm just using the times. Yeah? So everything I wrote over here is what you're using. The only part that we haven't really worked with is distance. So if it asks us for average speed, your problem now is you have to figure out how far they've traveled in each one. So that's what I don't know. So in this graph here, I don't know how far they've traveled each time. I don't know what the overall distance is. Okay, so that's when the questions get hard. Whereas what I'm doing right now is pretty straightforward. Find the derivative, sub in the values. Yeah? Now if you look at the last one, which is still nice, they didn't do speed. They said, what is the average velocity during the first second? So in the first second. Okay, so what is the average velocity from t equals 0 to t equals 1? What is my average velocity? Okay, so if we're answering C now, C, average velocity meant change in velocity over, sorry, change in displacement over change in time, which means where did you end up? Where did you start off? How long did it take you to get there? And what was the time when you first started? Now you know that I just said up here, we're moving from t equals 0 when you first began to t equals 1 because it says during the first second. So during the first second, you started the time up to 1. So it's duration of 0 to 1. So that means if I wrote out my information, this is what I have. I have t equals 1 is equal to 0. That's when I first started. My final time was at 1 second. I want to find the duration. My x1 is depending on what time it is at, or where my position is at t equals 1, which we found out here when t equals 1, my position, actually I still haven't found it out actually.
What do you mean?
Have I found it? Oh, we did. Position is 0. Yeah, so from here we got t equals 1, then position is 0. So therefore, I've got x1 is 0. I mean, x2 is 0. So if you want to find out what your position is at t equals 0, it's the same thing again. At t equals 0, your position is 0. So you have 0, 0. Okay? So if you're answering the question, what's your average velocity? It's going from x2 minus x2, x1, 0 minus 0, over 1 minus 0. It's 0 on average. Okay? Any questions there? Good. Okay.
Where did you get the T1 to X1 thing from?
X. I'm going back to this definition. Velocity is the change in x over change in time.
Yeah.
Change in x is the displacement.
Yeah.
So change in displacement means where I start in my position and where my final position is.
Yeah. So it's 0.
Yep. So my x1, x2 means when I start off at t equals 0, what is my position at t equals 0? Yep. So that was 0. That's why I got 0 and 0. And then at t equals 1, I also found out my position.
T like 1.5.
Yep, they could. Then you would have to say your displacement was given by t cubed minus 3t squared plus 2t. When t equals 1.5, you have to sub it in to find out your position.
Then, okay. Then one, so you grab them both from the first question. It was equal
Yep.
to 0.
Yeah, it was just so happens that it was from the first question. Normally, what you're meant to do is you're meant to sub in sub t equals 0 and sub t equals 1 to find out what your position is for each one. But we already knew that from the first question, so I didn't sub it in. Yes, John? After Melbourne Cup, which we said was like the 8th of November. So that's week 6. We're in week 4 now. Yep. Yep. I don't think there was probability. It was exponentials, log, circular functions, and calculus. We're in week 3. Oh, so it must be in week 5 then. Sorry. That means Melbourne Cup's week 5. Wait, I still haven't even done the second question.
Wait, did you say what question?
There was this other question that I wanted to work with you.
Why?
Because it has average speed, which you had to find out the distance. Like the first few are easy. Initial. I'm more interested in your average speed. That was the only one that you guys were finding confusing yesterday. But everything I'm doing so far is pretty straightforward. Well, I'm not going to make it in 4 minutes. I can do it in 4 minutes. Can I? Oh. All right, let's go. It's initial position. What does that mean? What do we do? Initial position.
Why did you just go straight to average speed?
T equals 0. Initial. Some of you said displacement equals 0. That's different. All right. Here we go. I'm going to do this. 12. Position's 12, and it's centimeters, okay? 12 centimeters. Next one, B. We are trying to find what is its position at t equals 5. So sub it in. 5 squared minus 7 times 5 plus 12. Whatever that is.
It's 20.
Minus 5 plus 12, which is 7.
That's minus 10 plus 12, yeah?
Damn it!
It's 2. All right, C.
3.
Next one. Find its initial velocity. To find velocity, you have to find the derivative. So v equals dx dt. Derivative of, that would be 2t minus 7. But you want to find initial velocity. So initial means t. Good. So therefore, v is equal to 2 times 0 minus 7, which is negative 7 centimeters per second. Next one, D. Actually, let's do over here, D. There we go. We can see the question. When does its velocity equal 0? So you're asking when is v equals 0, t equals what? That's what you're trying to find.
If we -7/2.
Good.
3.5.
Okay, so it's 3.5 seconds for it to have velocity of 0. Next one, E. What is its average velocity in the first 5 seconds? First 5 seconds means you got t equals 0 and t equals 5. That means find the velocity, you need displacement. So you need displacement when t equals 0 and displacement when t equals 5.
It's 12 and 2.
Okay, so this is 12 and t equals 5. Oh, we did do it. Cool, sweet. So average velocity, average vel, is equal to 12 minus 2, oh wait, no. 2 minus, yeah, you're right. 2 minus 12 over 5 minus 0. So final minus initial. Negative 10 over 5. Negative 2 centimeters per second. E, oh, we're there. Average speed in the first 5 seconds. So same thing again. T equals 0, t equals 5. I need distance now. Now this is where you have to draw the diagram to figure out the distance. So we draw out the diagram from the origin. T equals 0. My position was 12. At t equals 0, my particle sitting over here. T equals 0. My position was 12. So I'm 12 centimeters away. Okay? And then I move from here. T equals to... When was the next time I stopped? I stopped at 3.5 seconds. 3.5 seconds. So I kept going and going. At 3.5 seconds, I need to know where my position is. Okay, so after 3.5 seconds, I need to know where my position is. So the only way to find that out, sub it in. So x equals 2. Unfortunately, it gave me a really ugly number. It's going to take a while. Someone work it out for me. What's,
Root 3.
is it root 3? 3.5 squared minus 7 times 3.5 plus 12. What's that? 7 on 2 squared minus 7 times 7 on 2. 0.25? Negative. Okay, so that means negative 0.25 is my position after 3.5 seconds. Then I stop. My velocity stops. And then after I stop, I continue in a different direction and I finish at 5 seconds. So that means another 1.5 seconds, I end up at 2. So that's 2. Now work out all the distances. I went from here, I went to this. This is 12.25 distance in total. And I moved an extra 2. So my total distance, 14.25 over my time. That's my average velocity there. I mean average speed. So that's why it's hard. So what was hard is average speed. You have to draw the diagram. Start to where you start velocity to where your final point is. That's why this is hard. Okay? Hopefully at least you can do most of it. Average speed, if you're having troubles with that, keep practicing that average speed. It's finding the distance. You're doing all. 18F, there's only 8 questions. There's only 8 questions. Thank you.
Thank you, Mr. Tran.
And for those best students, you need complex. I want to help. Yes. I changed. I should stop the video too.